It started with a flicker, just a faint blip in the data. Something cold, silent, and fast moving through our solar system in a way nothing ever had before. Telescopes from Hawaii to South Africa caught it first. Then NASA confirmed it. A new object, uncharted, unbound by gravity's expected rules, and most terrifying of all, coming from outside our solar system. At first, it was just another rock. But within hours, patterns emerged: speed too fast, trajectory too perfect, reflections too bright. And when scientists traced its path, what they found made the blood run cold. It was headed straight toward the heart of the system. For decades, we believed that space is silent, still, and indifferent. But now, as this mysterious object barrels through our cosmic backyard, the James Webb Space Telescope has turned its gaze upon it. And what it has started to reveal is something we may not be ready for. Because some are now asking, what if this isn't just a visitor? What if it's watching us back? First detected between the 25th of June and 29th, the object now officially named 32, Atlas appeared on the radar of Atlas, a high-speed sky-scanning system designed to catch potentially hazardous objects before they surprise us. But this time, Atlas didn't find just another asteroid. What it caught was different. Its speed exceeded 152,000 miles per hour. Its orbit didn't follow any of the known gravitational loops of comets or inner solar system wanderers. And when astronomers reversed its trajectory through simulation, its origin pointed not to the Oort cloud, not to Neptune, but to interstellar space, possibly the core of our galaxy. This wasn't a leftover rock from the formation of the solar system. This was something that had been traveling through the dark for tens of thousands of years, unseen. And now it had crossed the threshold into our solar domain. But the deeper mystery wasn't just where it came from. It was why now. Because before 2017, we had never seen a single interstellar object. Now we've seen 3. And each one has been stranger than the last. After the initial confirmation, scientists around the world scrambled to get time on the most powerful space observatory ever built, the James Webb Space Telescope, designed to peer deeper into time and space than anything before it. Webb was now focused on something much closer and potentially much more unsettling. The object's brightness didn't match its apparent size. Based on the intensity of the light it reflected, it should have been massive. But measurements suggested something smaller, which means the surface isn't behaving like rock or ice, it's behaving like metal, highly reflective, cold, possibly hollow. Harvard astrophysicist Avi Loeb, who previously suggested that the 2017 object Oumuamua might have been artificial, once again stepped forward. He urged scientists to look for non-gravitational acceleration, small deviations in motion that can't be explained by the sun's gravity alone. If such deviations exist, they might indicate that the object isn't drifting but navigating. And if it's navigating, then we're not watching a rock. We're watching a decision. To understand how serious this discovery is, we have to look at the 2 interstellar objects that came before it. In 2017, Oumuamua burst into the scientific world with its strange elongated shape, lack of comet tail, and mysterious acceleration after passing the Sun despite showing no signs of gas or propulsion. Then in 2019, Borisov entered the picture, clearly a comet, yes, but faster and more volatile than anything seen before. With each of these objects, we were left with more questions than answers. But 32 Atlas is different. It combines the inexplicable brightness of Oumuamua with the trajectory of Borisov. It doesn't behave like a rock, but it also doesn't fit neatly into the category of a comet. And now astronomers are considering something even more radical. These may not be isolated events. They may be part of a pattern, a wave, a slow, deliberate sequence of contact disguised as randomness. Because for centuries, our skies were empty. Then suddenly, they weren't. And the only variable that changed was us. Among all the scientific papers, trajectory models, and observational data, lies one question that no institution wants to address publicly: what if it's not natural? When you remove everything that doesn't make sense, when the brightness is too high, when the path is too sharp, when the motion isn't gravitational, you're left with a possibility too terrifying for most to say aloud: artificiality. Not aliens in the Hollywood sense, not flying saucers and green faces, but probes, autonomous systems, artificial messengers sent long ago from places far away. Avi Loeb suggests we may already have missed the message from Oumuamua and that 3-2 Atlas could be our second chance. Its surface properties, its anomalous speed, and the timing of its arrival all point toward intentionality, or at least engineering. The James Webb Telescope will continue to monitor its thermal signature, spin, and trajectory. But what if the answers we're about to find aren't about what it is, but about who sent it? Because in a cosmos that's 13.8 billion years old, the most terrifying discovery wouldn't be that we're alone. It would be that we've been watched all along, and only now we're smart enough to notice. As days passed, the data from the James Webb Telescope and its supporting ground-based counterparts began to converge on something deeply unsettling. The object was accelerating ever so slightly, and not in a way that solar radiation could explain. This wasn't cometary outgassing. There was no tail, no particle plume, no traceable emission. And yet, the object continued to alter its trajectory, slipping past predicted paths with eerie precision. Webb's infrared lens confirmed a faint but consistent thermal signature. Not chaotic like an ice body, but stable, patterned, and directed. The anomaly echoed the same behavior seen in Oumuamua, where a similar unexplained acceleration prompted a quiet panic behind scientific doors. This time, however, it wasn't dismissed. It was measured, tracked, and now feared because the very act of acceleration without force suggests something else, something with control. And for the first time, scientists began to whisper in internal memos what they couldn't yet say on record. We're not just observing this object. We might be under observation, too. With Webb's advanced instruments aimed directly at the object, the team at NASA's Goddard Space Flight Center performed a full spectral analysis. They expected to find silicates, iron, ice, typical signs of celestial debris. What they found instead shattered expectations. The surface composition didn't match any known asteroid or comet profile. Certain absorption lines suggested the presence of advanced carbon structures, ones more commonly associated with engineered materials than natural geology. In layman's terms, it looked manufactured. Not only was the reflectivity unusually high, but there were hints of symmetry in how the object spun, something almost unheard of in random cosmic debris. One side absorbed more heat than the other, possibly indicating intentional design. Even more baffling, fluctuations in electromagnetic readings hinted at internal complexity, perhaps even cavities or layered density. Whatever this was, it wasn't a typical chunk of rock. And if it isn't a rock, what is it? That question began to echo from NASA's Jet Propulsion Lab to the European Southern Observatory to the classified halls of national defense agencies. Because if nature didn't make this thing, someone did. As public excitement grew, a new kind of silence began to settle in. Agencies that initially released trajectory data and light curves, NASA, ESA, and India's ASRO, suddenly pulled back. Mission pages stopped updating. Observational timelines vanished. Requests for raw Webb data were denied, citing internal review. FOIA requests submitted by journalists returned heavily redacted documents, and whispers began to leak from inside observatories. Researchers pulled from teams, specialists reassigned, access to telescope feeds quietly restricted. The public, initially fed a narrative of curiosity, was now met with closed doors. Why? What changed? Analysts in the astrophysics community began to suspect that something had been found, something extraordinary, and that governments were scrambling not just to understand it, but to decide what the public should be allowed to know. Because once a discovery reaches a certain threshold zone that challenges the frameworks of physics, security, or belief, it no longer belongs to the realm of science.